Welcome, everyone, to this MariaDB Fireside Chat powered by DZone Events. My name is Jesse, and I'm the Chief Technologist here at DZone. And I'm super excited to be here with Andy Oliver, the Senior Director of Product Marketing at MariaDB. Andy and I have been working in tech, databases specifically, since last century, and we've had a front row seat to a lot of changes in the database world. Now, there's a lot of trends that are happening now with the explosion of the cloud and distributed systems, but application performance at scale has always been one of the top issues and topics over all that time. And we've had some creative ways to try and solve that problem. Now, I don't want to pull my old timer card out, but in the past, we used to have something simple. We called it a box, a line, and a can diagram for our applications hooked up to databases. And we would debug those and figure out how to store information and go back and forth. But that no longer applies today. So to start us off here with Andy, let's take a look at some of the challenges with data architecture and cloud. Andy, what are teams trying to overcome when they're designing these architectures? There's a lot of different stuff than what you and I used to deal with. To bring us into the modern day, what are we trying to work on here?
So thanks for all that. And I feel like I should have a Gandalf beard since the last century. It's true when I think about it, but I really kind of feel like I should grow this beard a little longer and whiten it. But in addition to the sort of standard things that we've always had, which is performance, runaway queries, all that kind of good stuff, data sizes have gotten larger, and the way that we use computers has changed. So we use them a lot more and a lot more touch points. So the user volume or user traffic has gotten a lot larger. And then when we start to move to the cloud, things change even more, because now instead of, gee, you bought that can and you own the can, now you're leasing a lot of little cans. And the bill is running up. So just like you might turn off some lights and do some things to save on the electrical bill, you also don't want to run the cloud bill up too much. And I think many of us have already seen how much it can hurt when those bills come in.
But I forgot to take down my test instance.
Yeah. Yes. Your test instance of your big distributed cluster
it cost me $4,000. Yeah, it's huge. And it's part of that becomes, I mean, as we're talking about these challenges, this influx of data is because we're trying to store everything. We said bits are cheap. We're at one point, there was a saying, data is the new oil, right? That's the new thing that's valuable that people are trying to sell. We want information about who used our products, why they used their products, how long they stayed on, when did they click, all these analytics. And that kind of fed into this problem. And now all these mini cans everywhere, but were relational databases designed to handle all that?
No, in fact, even some NoSQL and some new sorts of databases really aren't set up to handle that. When you look at their overall arrangement, it's still a pretty hierarchical kind of cluster rather than a horizontal scale cluster. And in the cloud, you pay for a few things. You pay for, gee, when you had your can, you just bought the biggest can, and maybe eventually you bought 2 cans and replicated and what have you. But now, if you're doing that in the cloud, you're paying for more capacity than you need. And that bill's going to be huge. And the second thing is, okay, people get obsessed with the little how many pennies per minute or hour or second or whatever. But what they also miss is the big bill from AWS isn't actually that CPU bill when you're talking about databases. It's egress and IOPS and storage. So your IO type stuff. So in addition to that, you're buying this extra capacity because you don't want to disappoint your users, because, gee, back when we started, if the site got slow, we might be a little patient. We might hit refresh and /dot it, but we might be a little patient. Now, it didn't come up instantly, I'm gone, right? I mean, I'm not waiting around for this. Instant gratification now. So that's how your users are. But on the other hand, you don't want to pay for your best day of the year on your worst day of the year. So you need to right size that capacity while getting bigger data volumes, while getting higher write volumes, and all of that kind of stuff. And when we're distributing these big systems, if you've got a large enough system, some of the systems that you and I probably worked on, one of the larger systems, you know this, everything that can go wrong is going wrong all of the time, somewhere.
Right.
And availability zones fail. And while Amazon says they've never lost a whole region or even a whole AZ in the US, you do have regional failures on other cloud providers or around the world. So you have to just be prepared for any of these things to go away. And databases are not like other systems. So you have to make sure the data's over there as well.
Right. And we can get into the elasticity of the database, which is what we want, right? We can get into, I mean, you said NoSQL, and I remember when NoSQL first came out, right? And they even went as so far as to create a NoSQL-like language, Nickel N1QL.
Yeah.
And so there was
Which
this
was
idea.
SQL.
Yeah, it is. SQL plus plus is what it's called now, I think.
Yeah.
But it's interesting because a lot of those NoSQL databases didn't have the same transaction isolation levels that you would need
Right.
for a lot of things like financial applications or, you know, any of these highly sensitive transactional types of things. Even though NoSQL databases say they support ACID-like transactions, there's always a caveat, right? There's always something else
Yeah. Have you
that's
seen
in there.
the big web page or the big page on it on I think it's on Mongo's, where it's like here's all the disclaimers around these, and it's like, great,
Like
okay.
back when we
Oh,
had commercials, the guy that read really fast on the really small type, it's the
yeah.
same thing. So we've got all these problems, right? And we've tried to solve it a lot of ways. So what are some of the solutions that we've got or we've tried or we have that are available to this problem set, right? We've taken people through kind of the history, but what's available to us?
So people have gone through a lot of things, and a lot of data systems out there are still just replicated. They've got one write node and a bunch of replicas. And for systems of record where you need transactionality, and you don't have that many writes, that can be fine. It can perform well. You scale your reads.
Yeah.
If you look at something like Aurora or RDS and what have you, you can do multi-primary. Those help with availability. So you've got two write nodes. But people don't always realize that multi-primary doesn't actually help with scalability because it actually hurts your write performance because both write nodes are sending all their writes to each other. So you've halved your write speed at least. People have done a lot of sharding, and sharding is great, except that it's extremely difficult to maintain and keep going as time goes on. And depending on your sharding solution, it may be tough on the application developer. Anything tough on the application developer,
No good.
bugs.
And
Yeah,
that's no good anyway. I mean, the whole idea of the database is to be kind of this black box, like put data in and get it out. If I have to know the structure that
yeah,
deeply in some of these things, it's not, I mean, I agree with you. I think that one's a bad trade-off.
yeah, yeah. And they do other things of availability too, like hot standbys. But for sharding is great because you can split the writes across but yeah, like you said, that's really kind of a no-go for these sorts of volumes. When we are like, oh, okay, well, I just need twice the write capacity. Okay, I'll just divide, this and these over here, and it's a union. Who cares? But then now, well, that's not so much. Caching solutions became like the new hot thing. Cache is king, right? Caching became the new hot thing, and we still have some of these systems that are basically key value stores or whatever, front ending other data bases, and that's great to a point. Again, it gets complicated. Again, you've got cache management and all of these different deals, and you may still want to cache, especially for something simple lookups, but maybe your database should just be better at simple lookups. NoSQL databases, we tried those are good for scale, but they didn't provide transactions. While, as you mentioned, they do now, it's not the same exact thing that you're expecting for a system of record. It's not as easy to use. And each one has their own query language. And while Nickel and which is now SQL++, it's great because it's SQL-like at least. Most of them have their own language. And if you're a developer and it's JavaScript based, great. Although the dialect's getting a little dated, even for JavaScript developers working with it, they're like, well, this isn't exactly JavaScript as I use it anymore. And then on the other hand, most organizations have more than just developers accessing the database. There's a bunch of people with analysts in the title who the two things they know are Excel and SQL. And this database is a total black box for them. So what we are doing now is moving to distributed SQL databases. These keep the same transactionality, the same ACID properties, a relational structure, while integrating, like all relational databases did, JSON into them. So you can store JSON structures and other type of structures in them and map them to tables or map them to fields and do what you expect. But they're SQL, they're ACID, they're good for systems of record, but systems of record are moving to the cloud and systems of record are dealing with the same volume. It's no longer this divide where it's like, oh yeah, the cute little web thing for the young crowd, and then the real systems on the back end, like when we started. Now it's like, no, everything is got to deal with that volume.
Yeah.
And unlike these replication or couple masters or a couple primaries or any of that kind of stuff, now we have a horizontal structure that distributes the writes and distributes the reads. So unlike a normal relational database, that's the CAN and the client server, now we have a horizontal structure where any node can handle the reads, any node can handle the writes, but it automatically splits the data and distributes it across the cluster. So
That's
bigger
awesome.
data, bigger write volume, more read volume, and it automatically rebalances. So we're talking about that elasticity. It automatically handles that all together.
So I've got so many questions. First of all, it sounds too good to be true that I have full ACID. I've got elasticity in my data structures that scales with the cloud. The same elasticity I've been expecting on the application side and getting, not just expecting, but getting that. Now you're saying we can get it on the database side. And for those analysts out there who are using Power BI or Tableau, or you said they know a tool like Excel and they know SQL, they can use the same old SQL that they've been using that you can look up anywhere. So my real question is, as we get started here, how does this actually work? I mean, I'm thinking old school, how we're doing query processing and prepared statements, the whole thing. But if we can get into it just a little bit, if you could take us through that on how it works and why is it fundamentally different than sharding?
Okay. So at some level, it is sharding or similar to sharding. I've got a little diagram here. We start out with your table. It does essentially have in it some sort of distribution key. So I'm calling it a shard key. In my example, I've got it containing first name, last name, and US state. That creates a hash. The hash causes that row to be assigned to a slice, is what we call them in MariaDB Expand. They're called other things in other distributed SQL databases, but it's some slice of the table. That slice is then assigned to a node. And there's at least one replica of that. So it is essentially sharding, but it's a automatically assigned and managed sharding and automatically rebalanced. Rebalanced because I might lose a node, I might gain a node, so automatically rebalanced. So this is how data gets distributed. And if you think about it, great, now it's distributed across different nodes. The writes are going to be evenly distributed because we're taking the slices. So every write's not going to go to every node. It's going to go, let's say we've got one replica of each slice. It's going to go to two nodes for each row. Every read goes to one node. somewhere in the cluster, but they're evenly distributed due to the hashing algorithm. So it's
But
essentially
me, the developer, I'm still out of it. This is all you handling that on your side, right?
yeah, you don't, to you, it's just MariaDB. In fact, it speaks the same dialect. In the case of MariaDB Expand, our distributed SQL database, it speaks the same dialect as MariaDB MySQL. It has the same wire protocol. You can connect to it with your same tool sets.
Nice.
So as far as you're concerned, there's some little things you'll think about because it's a distributed database, like, oh, gee, maybe I don't want to use sequences. You can, they're still supported. Things you might want to do more efficiently, but it's MariaDB as far as you're concerned.
That's awesome. So this layout here with the pizza slice looks great. I know, want to talk a little bit about, for lack of a better term, right? I'll use old school high availability, right?
Yeah.
What happens? Like, how does this work if I lose a node? I mean, part of me is thinking, databases. I remember old school RAID systems at your hard drive
Yeah.
level. It's all about trying to make sure that this data is up when I need it, and it's fast reads and fast writes. So take us through a little bit about kind of your availability and how that works.
All right. So yeah, I've got, first let me show this sort of diagram of I only drew two zones, but you get the idea. So if we look table one, and I've called it partition one here, P1 is on two different nodes, node one and node two. And you notice that node one is in zone one, node two is in zone two, which means, gee, I've got redundancy. I've also got the read availability. And so if I were to lose a node, say I lose a whole zone, I still have that data on another node. It's resilient in that way. So every slice is essentially highly available, rather than thinking of it in the old school database where we're copying the same database to every single node. Well,
right.
Every node has a subset of the data. Yeah, so through this, I can lose a zone, I can lose a node, I don't lose data. I've also got data on multiple nodes, so I'm distributing my writes and reads across the cluster.
That's slick. So it's really neat. So if this stuff is if the slices are the things that are replicated and are in multiple places, recovery's got to be pretty quick.
Yeah, in fact, let me show what happens when a node goes down. I've got another here. What if I lose two? I've got node one and two. What if they go away? Well, then I'm going to end up needing to recover that so that the data stays resilient, right? Because if I've only got one replica of each, I can configure this and have more. But if I've only got one replica of each, what happens? Well, after I lose a node, now I'm in danger, right? So I could, if I lose more nodes, then I'm going to actually lose data. So in order to prevent that, the system will, if you look at the next sequence there, will go ahead and create a copy of that data on the other two nodes. It'll rebalance the data. So if you look at the next thing in the sequence, it'll rebalance the data and make sure the data is still evenly balanced across and the work is still evenly balanced. And if you look at the next, we end up in a steady state with four different nodes. So it's slide 6 there. So 4 different nodes. But on the other hand, what if we add 2 nodes? So, okay, those little nodes went away, it was on fire, life was bad, but now we're going to recover. Or maybe we took those 2 nodes away because we were having a slow day. Now we add these 2 nodes back on 7. We add these 2 nodes back. The system on 8 is going to copy those over, copy some of the slices over to the other nodes that we added. 9, it's going to move some of them from the other nodes, the ones they were on. 10, we end up rebalancing things because now we've got a 6-node cluster, so we want to make sure things are evenly distributed. And we end up on 11 with a totally even state. So we're kind of back to where we started. We lost some nodes, 2 nodes. We gained 2 nodes, and we're back to good. And that recovery, as you asked, it varies from distributed SQL solution. In the case of expand, we've tested it to be generally under 2 seconds, and then some of our tests even less. Now, you're not like down or something going to throw a bunch of connection errors or something like that. Just it takes a moment. It may have to pause to kind of rebalance some things, and then. But we're talking a as close to zero RTO as you can possibly get, because we're quickly just moving some stuff around, and we've got a way in expand of bringing up a node and saying, hey, you're not going to handle more than you can handle yet. So you've only got this amount of data. You can handle some stuff, but you're still in the kiddie table. And so it'll handle some stuff, but we don't have to wait for it to get fully rebuilt before it starts handling
Before
things.
you can start doing that. That's amazing, because I love it, because it auto balances, it does it quickly, and it remains available.
Yeah.
2 seconds can be, I mean, that can be, if you're dealing with nodes going down, that can be really, really fast. I like that.
And I'm being kind of conservative, because as you know, MariaDB went public, so but now I'm being kind of conservative. It can be faster. We have tested it. Of course, if you had a mega data set, who knows, it could be slower. But in our testing, that's about right. If you look at if you consider what it takes on a traditional client server database, or even some of the more newfangled ones, it takes a lot longer than that to get back to good.
You're actually having downtime at that point. So I love how the recovery works, but tell me a little bit about the queries and query processing, right? Reads, writes. I mean, that's kind of the meat and potatoes of this thing. This is the recovery aspect, which is 2 thumbs up. Hopefully I don't need it often, but how about the day-to-day? How about using it in an application?
Yeah, so what we've got is queries get distributed as well. And I don't think I pointed it out earlier, but in addition to the data being distributed, also the indexes are sliced and distributed the same way.
That's important.
So queries are then distributed.
Nice.
And if we look at this little diagram here, I've got a simple little query where select ID and amount from donation where ID equals 15. It pushes down fragments to the different nodes and distributes the requests to the different nodes that have the data. So queries are themselves distributing their workload. If you look at the next little diagram, we also scale joins. So
that's huge.
Yeah. So
joins are a pain.
Yeah, exactly. That's why NoSQL databases originally said, hey, NoSQL, and by the way, we're ditching joins. It's like one of the greatest marketing things ever, because it was like, hey, you're not going to get this anymore. Don't you love it?
I just want it fast. I want it to work, and I want it fast. We got to do joins.
Yeah, and then later everybody's like, well, here's your aggregation. AKA, yeah. So we scale the joins the same way. Data moves to which node needs it next. And so it can kind of go through in parallel. So if you check out the next diagram, which looks super kind of complicated, but it's basically showing that it's sending the pieces of the query to multiple nodes, and they're sending, they're all kind of working together, but in parallel. So parallel joins, scaling the joins.
Okay, what about analytics? Now, listen, real-time analytics. We mentioned it earlier, right? That we have these people that know application, whether it's Tableau or Excel or whatever you're using, and SQL. So you don't have to have a separate analytical database. You're telling me that this can handle it, right?
So to a point, if you're going through petabytes of data, then you might want an analytical database. And we've got ways to where you don't have to have separate ETL processes. You can kind of do this all in real time. But if what you need are sort of those lightweight analytics, like how many did I sell today? What's my supply chain look like right now? I don't want to know later on in a roll up or whatever. I want to know right now. We've got a columnar index. And if you look up at there on 15, this I got row storage is great. That's the normal. If we turn the database on its side, we end up with columnar storage of the same database. So we end up with we have columnar indexes, and if we're doing a range query, so from to or after this date, or whatever, those will be faster in columnar. If you look at 16 there, so one of the reasons they're faster, columnar storage is faster, is it compresses better. So when you've got a column and you turn it sideways, well, you've got repeat, 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 repeat. Well, okay, fine. We can page through those quickly. That ends up being super fast for range queries. It's also good for, gee, you've got a really complicated piece of data. You've got one perfect index, but then all of your other indexes are okay. And then you've got other queries and, you know, picking the right index and all that kind of stuff. Well, what if I could just do maybe not as good as the perfect index, but pretty darn good? Well, that's a columnar index. So ad hoc queries, real-time analytics, where maybe you're not going through petabytes, but you're going through intraday kind of analytics. Those sorts of things, you don't need a separate analytical database, or you don't need to wait for it to make it to the analytical database. You can look right now.
That's awesome.
So this is specific to, I should mention, to expand. I don't think any other distributed SQL databases have columnar indexes yet, but I think it's kind of a critical feature for modern kinds of cloud applications where you have ad hoc, you may have some real-time analytics, and you may not be able to create the perfect index for all of your queries.
That's really cool, but we're starting to run out of time. So if people want to try this, I'm sure you've got a place where they can try it out and see all this stuff for themselves, right?
Absolutely. This is the URL. You can gonna look at that for the expand on Docker. And if you don't want to install a bunch of stuff on your box, if you don't want to install these cans on your box, then you can go to the cloud version. We'll give you a $500 credit to the tires. Our SkySQL is our distributed, or is our database as a service. You can run both straight out MariaDB Enterprise Server, the more traditional. You can run SQL database. You can also run our columnar storage on there. So any of those are available on SkySQL. $500 credit to get started. And I'd also like to invite everybody to check out this URL and join us on our community Slack. If while you are trying, you know, I'd love to answer any questions people have. If while you're trying something else can do better, well, we at MariaDB will put our money where our mouth is. We've got a distributed challenge. So if you check out this URL, mariadb.com/expand challenge, we'll either pay 25K towards your shootout there, or donate the 25K to one of these charities if we lose. We won't lose, but if we do lose. So it's a safe bet for us. Yeah. So
I like the confidence.
Yeah.
I like it.
Yeah. So love to do that if anybody is interested. And then secondly, or finally, I'm happy to answer any questions, any and always, for as long as the bird site lasts. I don't know if it's been taken down yet, but you can find me on that, or there's my email address, community Slack as well. If you go to my Twitter, I think you can find my Mastodon account as well. So happy to talk to people there.
That's awesome. Andy, thanks so much for the time today. Learned a lot.
Thank you, Jesse.
And a lot of promises, right? A distributed SQL database that gives you scalable transaction processing, some, you know, at least operational analytics. And I still have the relational data model, keeping my ACID transactions. Sounds like it's something worth giving a shot. So thanks for taking us through that. And a big thanks to everyone out there for learning about this. Give some of these links that you see here a shot. If you want to stick around, we're going to have an open question forum with Andy. So start typing in your questions. And if you enjoyed this or you want to share this fireside chat, you can go to dzone.com/events and share it with all of your friends. And if you will, at the end of the questions, if you'll stay on for just a minute, we love to make all of our events better and fill out a really quick survey.